Good morning, students. In the last class, we discussed about the Warner's theory, which explains the primary valency and secondary valency of the coordination compounds. In today's class, I am going to explain you about the different terms which we are going to use in the coordination compound. First, I will write, and after that, I will explain, and after that, I will write the definitions of the respective. So, listen. If CO NH3 6 times plus 1 real 2 is understood. CO NH3 6 times R Cl2 plus 1 is there. R in the right, this one is Cl3. If you dissociate, how it gives? This will give plus 3 charge, this will give minus 1 charge, 3 minus 1 charge. You remember this thing? So oxidation state of this is plus 3. How to calculate oxidation state? I will explain you later, students. Just now you assume. So listen. So this is called as coordination entity. So the CO system is called as coordination entity. Okay. This one completely with the square bracket called as coordination sphere. Okay, so this cobalt is central metal atom. Okay, this NH3 is ligand. Okay, this is outer ion, and this is also called as ionization sphere. Ionization sphere, and this one is secondary. Central metal atom, ligand, secondary valency, coordination entity, coordination sphere, outer ion, ionization sphere, and this is also called as primary valency. Primary valency. Okay, so these are the terms which we are going to use often in this coordination compound. So what is this coordination entity? In a coordination compound, the metal which is bonded to the fixed number of ligands or fixed number of molecules is called as what? That coordination entity. Group. Entity means what? Group. That group consists of what? This central metal atom and a certain number of the ligands, and that ligands is fixed for the respective atoms. For example, CO is 6 times is there because its coordination number is 6. For copper is there, its coordination number is 4. For different compounds, different coordination numbers. Okay. So with respect to this, if the central metal atom is bonded to the fixed number of ligands, then it is said to be a coordination entity. Okay. Then this coordination entity is written in a square bracket. This coordination entity is written in a square bracket. So including that square bracket, it is called as what? Coordination sphere. Okay. So the central metal atom which is bonded to the ligand which is enclosed in a square bracket is called as coordination sphere. Okay. So in the last class only I told you students why coordinate. Why? Because the lone pair of electrons and the ligands is transferred to the empty d orbitals of the metal and the share between metal and the ligand. That's why they form what? Coordinate bond. Hence they are called as coordination compounds. So next, another one is ligand. So what is ligand and what is central metal atom? So I told you central metal atom is the atom in which the ligands are bonded in a coordination entity. To which the ligands are bonded. So where the ligands are bonded to the certain atom, that atom is called as central metal atom. Then what are ligands? The metal which is bonded by the molecules or a group of atoms called as what? Ligands. Okay? The ions or neutral molecules which are bonded to what? The central metal atom, that is called as what? Ligands. Okay? In that ligands, different types are there, as I told you. NH3 is there, Cl also taken, there may be neutral molecules as well as anions. So based on that, we again classify the ligands into different types. I'll explain students while explaining the ligands and writing the definition of the respective elements. So next, this Cl3 is called as counter ion, ionization sphere, and it is also primary valency. So why it is called as ionization sphere means if we dissociate, if it is a solid, if it is dissolved in a suitable solvent, then what happens? This entire complex is dissociates as +3, this one dissociates as 3Cl minus. So this will ionizes. That's why this is called as ionization sphere. That's why it is called as counter ion is because to balance the whatever the valency left on the complex ion, that is balanced by these. That's why they are called as counter ions. Okay, and primary valency means the first valency, if we consider the neutral molecules, this is plus in state means that the primary valency of this metal is satisfied by what? Primary valency means oxidation state. Oxidation state is satisfied what? Either the ligands or these counter ions. Okay, that's why this is primary valency. Next, what is secondary valency means? The number of ligands which are bonded to the central metal atom is called as what? Secondary valency. Okay. These are the terms we often use in the. Another one is there, that is coordination polyhedron. Coordination polyhedron means geometry of the complex. That is coordination polyhedron. So in this coordination polyhedron means based on the number of ligands bonded here, we classify them as linear, trigonal, tetrahedral, okay, square planar, trigonal, pyramidal. Like that, we will classify. Okay, that is called as a coordination polyhedron. So now, one by one, I will write the definition and the examples to the students. This is very important. They may ask them for a 1 mark. The definitions are important for 1 mark. First one is coordination entity. So what is coordination entity, dear student? So it is the group of atom or a central metal atom. Entity means group in which the ligands are bonded. Okay, so that is called as coordination entity. So we are going to write the same thing here. The definitions are important. As I told you in the given example, CO NH3 times is the coordination entity. Okay. Here it means the central metal atom bonded to fixed number of ligands. Central metal atom which is bonded to the atom bonded to a fixed number of ligands is called as coordination entity. So here, for this example is in Cu NH3 6 times Cl2. CuNH3 is a 4 times this is 4 is a coordination entity. Okay, next. Second, coordination sphere. Okay, the coordination sphere means the central metal atom and the ligands are enclosed by a square bracket. Enclosed by a square bracket called as coordination sphere. Okay, so here in this example, same example I take Cu is there, NH3 4 times Cl2. So in this, which one is the coordination sphere? Cu NH3 4 times with the square bracket is a coordination sphere. Understood? So the coordination sphere means the central atom and central metal atom and the ligands are enclosed by a square bracket. Next one is third one. Central metal atom. Okay. So this in a coordination compound the ligands or the atom which is bonded by ligands called as central metal atom. In a coordination compound, the atoms which is bonded by ligands is called as what? Or instead of bonded, we may take coordinately bonded. Is coordinately bonded with by ligands. So in the same example, take CuNH3 4 times Cl2. So Cu is the central metal atom and this NH3 is the ligand. Okay, Cu is the central metal atom and NH3 is the ligand. Next one is the ligand, students. I hope you wrote all these definitions. So I'll go with the ligands. So coordination entity, coordination sphere, and the metal atom. So the next one is here, the central metal atom, as I told you, accepts a pair of electrons, so it is a Lewis acid. Okay, so the next one is ligands. So what are ligands, students? The atoms or molecules, especially neutral molecules, ions or molecules, not atoms, ions, because anions are neutral molecules. Ions are molecules bonded to the central metal atom. Central metal atom which satisfies secondary valency. Secondary valency called as ligand. So in the example, as I told you, CuNH3 4 times Cl2 is there. This NH3 is a ligand. Okay, so in this ligand, students, again the price is there. Based on the number of the donor atoms, it is classified into what? Unidentate. Okay, bidentate or didentate. And polydentate. Another one is there. This is what? Based on number of donor atoms. Another one is there, that is fourth one. That is ambidentate. I'll explain one by one, students. So ligands means the ions of the molecules bonded to the central metal atom which satisfies secondary valency. So in that, types is there based on the number of donor atoms, that is unidentate, bidentate and polydentate. Based on the nature of the donor atom, it is classified as ambidentate and also chelating. Another one is there, that is chelating ligand. So these two are equal, same students. Chelating as well as this. Right? Bidentate is itself called as chelating. Not only bidentate, okay, I will explain later. Chelating, now you will listen. So unidentate means which has only one donor atom. Which has only one donor atom. So example is NH3, H2, okay, Cl minus, Cn minus, OH minus, O2, OH minus, okay. So here one lone pair electron is there, here lone pair electrons are there, here Cl minus is there, extra electron. So in these things, students, Cn will not come, okay, Cn will come, unidentate. So they donate only one lone pair of electrons and results in the formation of the one coordinate bond. So this type of compounds or ligands or molecules, this is ions, this is neutral molecules, is called as unidentate ligands. The ligands which have the capacity to donate only one lone pair of electrons, or the ligands which have the capacity to form one coordinate bond, they are called as unidentate ligands, which have the capacity to form one coordinate bond. Okay, next. Pi means, of course, two. The ligands which has the capacity to form two coordinate bonds, or they have the capacity to donate two lone pair of electrons, then they said to be one bidentate ligand. So example, N, ethylene, dynamine. And we also write ethane 1,2 diamine. So this is very important for 1 mark student. The name of the ethylene diamine or ethane 1,2 diamine. Okay. So what is the structure? Ethane means CH2. First position and the second position, nitrogen atoms are there. NH2, NH2. Here on the nitrogen atom, 2 lone pair electrons are there. So these, from this nitrogen 1 lone pair, from this nitrogen 1 lone pair, the both the nitrogen atoms can act as a donor atom. So they are pi-dentate ligands. Okay, in the same molecule, they have 2 donor atoms there. That's why they are pi-dentate ligands. So another one example is oxalate. That is CO minus. Okay, students. Here it is. Here also lone pair electron is there. Here also lone pair electron is there. So these all forms pi-dentate ligand. Okay. So this is pi-dentate ligand. Unidentate means only one donor atom is made with the formation of only one lone pair electron. Bidentate means 2 donor atoms. It has the capacity to form 2 coordinate bonds. Okay. Polydentate means the one best example is means it consists of more than 2 donor atoms. It can be tridentate, tetradentate, pentadentate, hexadentate. So the best example for polydentate is EDTA. EDTA means, alright, ethylene diamine tetraacetate. Ethylene diamine tetraacetate. So students, ethylene means CH2, diamine means here NH2, tetraacetate they said means this H2 is replaced by 2 CH3 CO minus atoms. CH3 CH2 CH2 CO minus CH2 CO minus. Here nitrogen is there, here lone pair electrons are there, here 4 oxygen atoms are there. So from 4 oxygen atoms they have the capacity to form 4 dative bonds. They do nothing but coordinate bond. From these 2 nitrogen they have the capacity to form 2 coordinate bonds. 2 from nitrogen and 4 from oxygen, total 6 coordinates they can form. That's why it is called as hexadentate ligand. So ethylene diamine is hexadentate. Okay, it is hexadentate ligand. So remember one thing, students. So this EDTA and this structure is very important for 2 marks. So I am writing here which one is important for 1 mark, which one is important for 2 marks. So diamine name of this ethylene diamine, ethane 1,2 diamine is important for 1 mark, and the structure of EDTA that is important for 2 marks. Okay, so this is unidentate, bidentate and polydentate based on what? Number of donor atoms or the capacity of the formation of the dative bonds. Here you can form the one bond, one coordinate, unidentate, 2 coordinate bond, bidentate. More than 2 means that is polydentate, especially EDTA is hexadentate. It has the capacity to form 6 coordinate bond. Okay. So next we will discuss ambidentate and the chelate. You remember these things. This is very important, students. Okay. Now I will go with ambidentate. That is fourth one. Ambidentate. dentate. So what is ambidentate ligand? The ligand, especially unidentate ligand. The unidentate ligand which has more than one donor atom. So the unidentate ligand which has more than one donor atom called as ambidentate ligand. So I will give example. Cn minus is a unidentate ligand, correct? So through this what happens? So Cn minus is there. So this is cyanide. If it is bonded through this carbon, okay, so Cn means it is in this form. Correct? Here also lone pair electrons are there, here also lone pair electrons are there because of the minus charge. So, if the lone pair electron is transferred or this is bonded to carbon, then it is cyanide. If it is bonded to NC, means nitrogen, then it is isocyanide. Understood? So Cn and Nc are the same ligands, but in the same ligand, unidentate ligand, that is minus one charge. What happens? It can bond it to carbon as well as it can bond it to nitrogen. If it is bonded to carbon, it is called as cyanide. If it is bonded to nitrogen, it is called as isocyanide. Okay? So this is the example for a set of ambidentate ligand in the same donor atom. The same unidentate ligand, same ligand, two donor atoms are there. Similarly, SCN so bonded to what? Nitrogen. That is thio bonded to sulfur means that is thiocyanide. If it is bonded to nitrogen NCS, that is isothiocyanide. Understood? This is thiocyanide. This is isothiocyanide. Both the ligands are same, but here sulfur is also a donor atom. Nitrogen is also a donor atom. So in the same ligand, both two donor atoms are there. Similarly, NO2. If it is bonded to nitrogen, then it is nitrato. N. So it is bonded to nitrogen, oxygen means this is nitrito O. Understood? So these are examples for the ambidentate ligands. Understood? The unidentate ligands which has more than one donor atom in the same ligand. Here Cn is the only one ligand. Here carbon is also donor atom, nitrogen is also donor atom. Here SCN is the only one ligand. Here sulfur is also donor atom, nitrogen is also donor atom. So this type of ligands is the example for ambidentate ligands. So another one is there, as I told, that is chelating ligands. This is not a type actually, students. It is a structure. Chelating ligands. So chelating ligands means if more than two donor atoms are there, then what happens for a bidentate or hexadentate or polydentate ligands, for any metal atoms is there, and then this is ethylene diamine, NH2, CH2, CH2, NH2. Correct? Next, NH2, CH2, CH2, NH2. So students, here you assume copper is there. Copper, its oxidation state is +2 in the coordination compound and its valency, secondary valency is 4, that's why it is. So here also lone pair electrons are there, here also lone pair electrons are there. Then they form a coordinate one like this. Correct, students? So then what happens if it is a metal, copper, then it forms a ring-like closed structure. Means enclosed structure. That enclosed structure is nothing but chelating structure. The ligands which form a enclosed structure with the central metal atoms are called as chelating ligands. Chelate means it is enclosed structure of the formed by this cyclic structure formed by the ligands in which the two or more donor atoms are there. Means bidentate, tridentate and a polydentate. Now it cannot be possible in unidentate. Okay, it is possible only if bidentate and above donor atoms are there. Understood? So these are the types of ligands. So the next one is I explained coordination entity, coordination sphere, and then types of ligands, central metal atom, and what is ligand. Now we will study what is counter ion. Okay, fifth one, ionization sphere are counter ions. The sphere outside the coordination sphere is called ionization sphere. Or you may take it for counter ion also. Okay, the ions present outside the square bracket called as counter ion. So in the example, CuNH3 4 times Cl2. This Cl2 is a 2Cl atom or Cl is a counter ion. Understood? Yes, Cl is a counter ion. So the next one is coordination. I will say first secondary valence. Secondary valence. The number of donor atoms bonded to central metal atom called as secondary valency. The number of donor atoms bonded to the central metal atoms is called as secondary valency. That is especially donor atoms of ligands. Donor atoms of ligands which are bonded to the central metal atom, that is called as secondary valency. So in the example, CuNH3 4 times Cl2, this is the 4 is the secondary valency. Okay, students. So this is about the terms. Another one is there, that is coordination polyhedron. That is the structures in which the metal atoms represents. Okay, I'll explain that one. So the structures in the next class I will explain the remaining things. So in today's class I will explain the structures, only the shapes. Okay, listen. 8th one, that is coordination polyhedron. That is three-dimensional spatial arrangement of atoms called as coordination polyhedron. So in that different structures are there. Okay. So we are going to study about the structure, students. Then the first one is octahedron. M is there. If it is bonded to this type of ligands, then you form an octahedral structure. So for this, coordination number is 6. Okay. Next, tetrahedral. So M this is L, and L. This is the tetrahedral structure. For this, coordination number is 4. Okay. So another one is there for the coordination number 4, that is square planar. I will write here only M This is square planar structure. For coordination number 4, two types of structures are there, tetrahedral as well as square planar. So another one is there, that is last one, that is trigonal pyramidal. So here what happens, students? M is there. This is triangularly bonded, this trigonal and bipyramidal structure. So here coordination number is how much? 5. So for this coordination number 5, another one structure is formed. Can be formed. That is square pyramidal. But it is square pyramidal. So these are the structures, the standard structure we are going to use for the different coordination number. Coordination number 6 is there, octahedral. 4 is there, either tetrahedral or square planar. Coordination number 5 is there, either trigonal bipyramidal or square pyramidal. Okay, so this is all about the coordination polyhedron. Another one is there, that is oxidation state of the central metal atom. During nomenclature, I will explain how to calculate the nomenclature, oxidation state, and how to write the name of the complexes. Okay, in the tomorrow's class we will discuss about nomenclature. Thank you.